So this video is on Chapter 7, D-Day number 2, Part A. So this is on our logarithm section. Okay, we're going to have a Chapter 7 D-Days Part 1 and 2, but I mean, sorry, 1 and 2, but they're going to be Part B. That's going to be on law of sines and law of cosines. So let me just get this up on my screen. Okay, so very similar to the problems we were doing the last D-Day. Okay, so I am going to be putting in these 2 points for my X and my Y. Okay, so let me do that. Okay, so again, this is Y equal A times B to the power X. So I'm going to have 24 equals, let me get a little darker. Okay, start again. I'm going to zoom in a little bit more. Okay, so we're going to have 24 is equal to A times B to the third. Okay, and then I'm going to be putting in the second point for my X and Y. So I'm going to get 294 is equal to A times B to the fifth. Get that back here. A times B to the fifth. And what I would recommend doing so that the math is a little easier, always try to get one of these to be either A equal or B equal, because we're going to substitute. It is much easier to get them to be A equal than B equal because of the exponents. You're going to have to root it. And so when you're deciding which one should I solve for A, always do the one that has the smaller exponent. It's going to make your math easier down the road. Okay, so don't do it for the one that has the bigger exponent, do it for the one that has the smaller exponent. So I am going to get this to be A equal, and so I'm going to divide both sides by B to the third. So I'm going to get 24 over B to the third is equal to A. And I'm going to be substituting this into this equation here for A. So I'm going to put it in place of this A. Okay, just do that in orange. So it's going to go right there in place of that A. So let's see, I'm going to have 294 is equal to, and instead of A, I'm going to be putting this. So 24B to the third times B to the fifth. And this is why I wanted to solve for the one that had the smaller exponents. So now these B's can cancel with these ones, and I won't have any B's on bottom. Okay. If I had done the B to the fifth solve for this one, I would have had more B's on bottom. That just makes my math a little harder. So I am going to cancel these B to the third with 3 of these, and I'm going to be left with a B squared here. And so now when I rewrite this, let me put it up here, I am going to have 294 is equal to 24B to the second, okay? And I'm going to solve, so I'm going to divide both sides by 24. So 294 divided by 24 is 12.25, okay? So it's going to be 12.25 is equal to B to the second. Okay, now if I want, I could change this to a fraction. So if I hit math, number 1, we'll change it to a fraction. I'm just going to see if it's a nice fraction. It's actually a nice fraction. It is a 49. Here, let me focus that better. It is a 49/4. Okay, so if you don't want to have it as this decimal, 49/4 is nice. Why? Because when I take the square root of both sides, the square root of 49 is 7 and the square root of 4 is 2. So this is really 7 over 2 is equal to B. And I could have just taken the square root of this also. So if I was to take the square root of, whoops, wrong button. If I was to take this square root, sorry, clear. Okay. If I was to take the square root of 12.25, I'm actually going to get this as a decimal 3.5. So that's okay too, but sometimes these actually are nice fractions. So if you have it as kind of a decimal, this decimal is not bad. Sometimes they can be a little worse. Sometimes it might be a nice fraction, so you might check that out. Okay, so this is a 7/2 or a 3.5, okay, whichever way you want to think about it. Now I'm going to be putting that in place of this, okay, to find my A. So I'm going to have 24 over, and this is going to be 7/2 or 3.5 if you prefer, to the power 3 is equal to A. So I am going to put that into my calculator. Okay, so I am going to take 24 divided by, and I can do 7/2 raised to the third power. And you see, I'm getting something that doesn't look so nice, but if I hit math and fraction, it actually ends up being maybe not something beautiful, but it is something that is a decent fraction. I mean, it is a fraction. So my A is equal to 192 over 343. And so instead of having to write out this decimal, I can just keep it as this fraction. So this is going to be y equal 192 over 343. That's my A, times 7/2, oops, 7/2 to the power x. Okay, and this 7/2 to the power x. And that is my answer. Okay. Not the prettiest numbers, but again, when I put this into my calculator, it did look like a decimal. That wasn't so nice, but when I change it to a fraction, it actually is doable. Okay. So now, next one. On this one here, this one you're supposed to evaluate without a calculator. So what we're going to do is we're going to rewrite it in exponential form. This is really 1/4 to some power is equal to 1 over 64. So we want to figure out what power I'm raising it to. Now, 4 to the third is 64. So that means that x is going to be 3, because if I take 1/4 times 1/4 times 1/4, I'm going to get 1 over 64. That's your answer. On B, I am going to take 81 to some power and get 27. Now, in this case, what I'm going to do is I'm going to figure out a same base for both of these. 81 is a 3 to the 4th, okay, being raised to the power x. And 27 is a 3 to the 3rd. It is important that you guys understand when you see an 81 and a 27, you guys understand that these are 3 to powers. It just makes the math a lot easier for yourself. Now, over here, power to power, I multiply, so it's going to be 3 to the 4x is equal to 3 to the 3rd. When I have the bases the same, 3 to something equals 3 to something, these two things have to equal each other. So that means that 4x is going to equal 3. And so x is going to be 4/3. Or sorry, 3/4. And that's going to be my answer. Okay, next one. This one here, again, this is saying 5 to some power is equal to 5 to the pi. So here, as even though it looks kind of scary when you see it, this is 5 to something equals 5 to something. So you set your exponents equal. There you go. That's your answer, pi. Done. So now we're going to move to the next section. Okay, so on these problems from this chapter where we're solving, you're going to have certain situations. One is where you're going to have like an exponential, and your goal is to get it to be a base to a power by itself. I want to get rid of this -8. I want to get rid of this 2. Then when I get it to be 6 to a power equals whatever, you're going to log both sides. Then the other problems are going to be dealing with logs. Either you have log on both sides, or you have a situation where you have log on one side and a number on the other. Those are the 3 types that you need to know how to solve. Okay, now for this, again, I'm going to add 8 to both sides. So I'm going to get 2 times 6 to the x is equal to 252. I'm going to divide 2 on both sides. And so I'm going to take 252 divided by 2, and I end up with 126. And now you can sit here and try to think of 6 to what power gets you 126, but it's not 6 to any nice power. 6 to the third, for example, 6 squared would be 36. 6 to the third is too much. So I know it's somewhere between 2 and 3. So when you get it to this form, what you're going to do is you're going to log both sides. Exponentials and logs are inverses. That means they undo one another, like squares and square roots. So you might say, well, how do you do that? I'm actually going to take log of this side, and I'm going to take log of this side. There you go. I'm just logged both sides. Now, we learned that if you take log of something to a power, the power moves in front. So that power is going to move in front. And so I'm going to get x out of the exponent. I need to get x out of the exponent in order to solve, okay? Because I want to try to get x by itself. So it definitely has to come out of the exponent. Then what I'm going to do is I am going to divide both sides by log of 6. And I put this in my calculator at the end. I don't do this and get decimals and have to, let's just do it all at the end. So I'm going to have log of 126 over log of 6. And I'm going to put that into my calculator, okay? So sometimes what I'll do is this is division, but you got to make sure you close your parentheses or else you're not going to have the right order of operation. So sometimes just to avoid problems with order of operation, I actually will enter it in as a fraction, alpha y equal. And again, so it was alpha y equal, and I get fraction. And I'm going to put log. Okay, this log button is log base 10. That's what we're dealing with. When there's no base, it's a base 10. 126 over, get that clear off, log of 6. And I get about a 2 point, let's say about a 2.7. Okay, about a 2.7. So it's about equal to a 2.7. And that's your answer. Okay, so that's what you do when you have a base to a power. You try to get it by itself, and then you're going to log both sides if you can't get the bases to be the same. Okay, next problem. Okay, this is one of the log type of problems. This one we have log on one side, number on the other side. Okay, now you always need to get your log to be a single logarithm here. So when I'm taking a log plus a log, that means I'm going to take log of the product of these two things. So log base 2 of, and I'm going to be multiplying this out. So you guys need to understand how to multiply this out. Some of us are good with this. Some of us are still kind of trying to remember from integrated 2. Quick little note, okay? You can do it like this. You can go x plus 4 times x minus 3 and work it out that way and get x squared, 4x, negative 3x, and a negative 12. And when I combine that, I get x squared plus x minus 12. Now, when you have something like this, again, where these are both x's, you can also kind of think of it as a diamond problem, where your 4 and your negative 3 are your sides. These multiply to a negative 12, this number right here, and these add to a 1. That's how many x's you have. okay? So it's very important that you guys understand how to solve quadratics, because most of these problems we end up, it started as a log and it ends up being a quadratic. Okay, equals 3. So now that you have it as a single logarithm, just like over here when we, on the other last one, when I got it as an exponential by itself, logs undo exponentials, exponentials undo logs. So I'm going to write this in exponential form. Base 2 power 3 equals x squared plus x minus 12. The base 2 to the power 3 equals this. Now 2 to the third is 8. And so I get x squared plus x minus 12. I'm going to subtract the 8, and I get x squared plus x, and I minus 8, I get a negative 20. And I have to solve this quadratic. This quadratic is actually factorable. And just like I multiplied this out using a diamond, I can factor this using a diamond, okay? This time, I don't know the sides. I know the top and I know the bottom. What multiplies to negative 20 and adds to a 1? A 5 and a negative 4. Okay, again, this is review from integrated 2. Our main focus in integrated 2 was quadratics. So now I'm going to solve this quadratic. What makes this 0? Negative 5. What makes this 0? A 4. Now with logarithms, you have to be careful because you can never take log of 0 or a negative. It has to always be a positive value. So you always want to come and check in your original logs up here. If I put negative 5 in here, it's going to make this negative. That can't be an answer then. No. If I put this 4 in here, it makes both of these positive. So that means this is going to be an answer. Okay, on letter C, this one is one, just like the last one, but a little easier in the sense that it's already as a single logarithm. So this is going to be one that I rewrite in exponential form. 9 to the second is equal to 3x minus 4. 81 is equal to 3x minus 4. 85 is equal to 3x. I am going to divide both sides by 85, and I'm going to get 85 over 3 is equal to x, and just leave it like that. That's going to be your answer. Again, you want to check to make sure that this is not going to be negative, but when I put 85 thirds, 3 goes into 85 way more than 4 times, so this is definitely going to be something bigger than this. It's going to be a positive. If you're not sure, put it in your calculator. Put this in here. 3 times that minus 4. Make sure it's positive. Okay. Next one. Let's say, let me just erase that. Okay. So for the next one, this is like the one above where I have 2 logs and I need to make it into a single logarithm. So I am going to take these, make this into a single logarithm. Now for this, on this one, what I personally would do is I notice there's a 2, a 2, a 2 in front of it. So I would divide everything by 2, and I would get log base 3 of x minus log base 3 of 6 equals 1. Makes it a little simpler. And then now I'm going to make this into a single logarithm. Sorry. Make this into a single log. Okay. So this into a single log. So this is going to be log base 3 of something. okay? And when you have a minus, that ends up being a division. So this is going to be x over 6 is equal to 1. So now that it's a single logarithm, we can rewrite in exponential form. 3 to the first is equal to x over 6. So that's really just 3 is equal to x over 6. I can multiply both sides by 6, and I get 18 is equal to x. And again, you want to come check to make sure that it's going to keep your fraction, your log positive, taking the log of a positive, and it is. And that's your answer. Okay, next one. So this one, you have logs on both sides. So this is slightly different than the ones we were doing. Okay, so this is that third type. A is one type, B and C. So A is one type, B, C, and D is another type, okay? And then this is a third type. So first off, you want to get this to be a single logarithm. And again, there's a plus here, so I'm going to be multiplying these. So this is going to be log base 6 of, and I'm going to do the diamond to multiply this. I have an x plus 2 and an x plus 3, so I have a 2 and a 3. Multiplies to 6, adds to 5. So this is going to be x squared plus 5x plus 6 equals log base 6 of 20. Okay, let me just get rid of this. It's out of the way. Okay, so now that I have a log equal a log, I can take what we're taking log of and set them equal to each other. So I can only do this when both sides are logs. Otherwise, I have to rewrite it in exponential form. Okay, so now I'm going to solve a quadratic. Again, a quadratic. So I'm going to get x squared plus 5x. I'm going to subtract 20. I get a negative 14 is equal to 0. I am going to divide, I'm going to factor this, sorry. And so again, if I'm thinking of this as a diamond, what multiplies to negative 14 and adds to 5? That's going to be a 7 and a negative 2. So this is going to be an x plus 7 and an x minus 2 equals 0. And I want to solve this. So this is going to be x equal negative 7 and x equal 2. Again, take your answers. Negative 7 is going to make this negative. So that is not going to be an answer. 2 does not make either one of these negative. That's your answer. Now, F is a similar problem in the sense that at least it looks like a similar problem, but you'll notice this minus 1. This minus 1 really has nothing to do with this here. So what I personally would do is I'm going to bring my negative 1 over here, making it a positive 1. And I'm going to bring this log over to the other side. So I'm going to have log base 7, and here, let me just move my 1 over a little bit, give myself some space. So I'm going to have log base 7 of, I'm going to put parentheses. It's log of 3x. There's no parentheses around this whole thing. That minus 1 has nothing to do with that. So again, I'm going to bring that 1 over. I'm going to minus log base 7 of 9. Okay, so I'm moving this over here. I'm subtracting it. And then I'm going to add the 1. And so now I have this problem. So when we're doing a problem like this, there's a minus. That means these are going to be dividing when I write it as a single logarithm. So log base 7 of 3x over 9 is equal to 1. Now I can simplify this 3 over 9 if I want, but let's just rewrite this. So it's going to be 7 to the first is equal to this. 7 to the first is equal to 3x over 9. And now I'm going to solve this. Now this is just a 7. And here, let me simplify this. This is really an x over 3. Okay, 3 goes into both of them. I'm going to times both sides by 3 here. I get x is equal to 21. Again, check to see if it makes it 0. It doesn't. Or I should say negative or 0. So 21 is your answer. Okay, so now the next set of problems. So for these problems, we're going to be expanding our logarithm. So I'm going to write a log for the A and a log for the B. Okay, these are multiplying together. The one thing you want to make sure you understand is this right here. Let me do it in green. This right here, do it in a see-through green. This right here is really going to be b to a power, okay? So I can rewrite that as b to the 2/5, 2/5. 2 because of this, and anytime you root it, that means that's going to go on bottom, okay? So now when I rewrite this, I am going to have log base 2 of a to the third, I'll start it out that way, plus log base 2 of b to the 2/5. Now, when you have a log of something to a power, the power moves in front. So this is going to be 3 log base 2 of a plus 2/5. Again, the exponent moves in front, log base 2 of b, and that's your answer. That's expanded. Okay. Number 5. We're going the other direction. We're going to be writing this as a single logarithm, and it also says simplify if possible, so that we might be able to clean up our answer at the end. Okay, right now, I couldn't do any of this in my head because 2 raised to no nice power is 5 or 15. So now this part right here, well, let's kind of clean this up. So this part right here is a 1. Log base 2 of 2 is 1. So I want to see if that's going to be helpful or not helpful. So let's kind of just work this out. So first off, here, why don't we just do this? I'm just going to write it as log base 2 of something. Okay, I'll write it as a single logarithm. Since I have a minus, I know I'm going to have a division part in here. This 3 log base 2 of 5, the 3 is going to become the power. So I have 5 to the third, okay, which is 125, but I'll just leave it as 5 to the third right now. This minus means that I'm dividing, so this 15 is going to be on the bottom. And then this plus means that this is going to be on top, multiplying on top. So I'm going to have times 2. And so now let's see what I get here. So I am going to get log base 2 of, now I'm going to kind of simplify this a little because this is 3/5, so that means that I can take a 5 from here, and now I have a 3. Take a 5 from here, and now it's a 5 squared. And so this is going to be 25 times 2, which is 50 over 3. And that's going to be my answer. Log base 2 of 50 over 3. Can't simplify that any more. Okay. So this log base 2 of 2 is a 1. That didn't help me out in this situation. If that led to me getting like a single log, that would be fine. But having a +1 on the outside is not going to be helpful. Okay, the 2 graphs that we need to understand from this chapter: graphing logarithms and exponential. So here's an exponential, over here's a logarithm. This -4 tells us that our asymptote is y equal -4. So I'm going to come down here. I'm going to extend it. They didn't give us enough room on this graph, did they? And so let's pretend that we extended this. Let me start fresh. So I'm going to extend this, and so this is going to be 1, 2. Okay. So I'm going to go down 1, 2, 3, 4, and that's where I am going to have my asymptote right here. And again, it's at y equal -4. And then this is 4 to a power. So at this point, my graph is not being moved left or right. It just got moved up or down. So I'm going to come here to where my asymptote touches the y-axis. And now I'm just going to do basically 4 to powers. 4 to the 0, 1. I move over 4 to the 1, 4. 1, 2, 3, 4. I go over 2, 4 squared, 16. Don't think I'm going to have enough space for the 16. So I am going to just draw this. And here is my exponential graph. Okay, so I was 1 high, then I was 4 high, and then I'm timesing by 4 again, 16 high, times it by 4 again, 64 high, but it's not going to fit. B, this is a logarithmic graph. So right here, that tells us that our asymptote is going to be at x equal 2. So I am going to come here to x equal 2. There is my vertical asymptote. The plus 5 means that I'm going up 5. So you can kind of think of 2 comma 5 as kind of a locator point. So 2 puts me on the asymptote, 1, 2, 3, 4, 5. I'm just going to put a little mark. This is not actual part of my graph. Here, I'll do it in yellow. 1, 2, 3, 4, 5. Okay, kind of faint there. This is where I'm going to be going out. 1 and 3 and 9 and 27. And if you're going, why are you going out those numbers? Because my base is 3. And so when I'm graphing, log base 3 of 1 is 0. Okay, you got to know these numbers. Log base 3 of 3 is 1. Log base 3 of 9 is 2. So again, I come to where my vertical asymptote is. I go up to a height of 5, and then from here, I'm going to go out 1. Log base 3 of 1 is 0, so I'm not going up at all. I go out 1, 2, 3. Log base 3 of 3 is 1. I would go out 9 and go up 2, but that's not going to fit on my graph. So let me just sketch the rest of this. It's coming like this. And there you go. That is your logarithm graph. Now, the next set are review questions. Okay, so the rest of this has been from this chapter. The next set are review questions. And these are on inequalities from our last chapter. Okay. So when I'm doing these, for an absolute value, get your absolute value by itself first. That's the first thing you want to do. So it is isolated. So then what you're going to do is you're going to write 2 equations. 4x plus 1 equals 17, and 4x plus 1 equals negative 17. And then you're going to solve these to get your boundary points. So you're going to have 2 boundary points. You're either going to shade between or you're going to shade out. So I'm going to get 4x is equal to 16. I'm going to get x is equal to 4. 4x is equal to negative 18. X is equal to negative 18 over 4, or a negative 9/2. Either one's acceptable. So I'm going to plot those. Negative, let's say I keep it as a 9/2, make it a little nicer, and 4. So I now need to look at my original problem, and I need to decide if this is something that has an open circle or a closed circle. Because of the equal, these are going to be closed. Okay, these are going to be closed. Then I need to decide, do I shade in between or do I shade out? So you can test a point, a number. So 0 is a nice number to test. So if I was going to test 0, let me do it in orange. That means I would put 0 in here, and I get absolute value of 4 times 0 plus 1 is greater than or equal to 17. And I want to see if that's true or false. Well, this is going to end up giving me 1 is greater or equal to 17. That's false. 1 is not bigger than 17. So since 0 is here, I'm not shading here. That means I'm going to shade out. Okay. Now, when I personally do these problems, I think about it this way. if this is absolute value, okay, I want it to be more than 17 away. Less than 17 away would be in between, okay? More than 17 away would be kind of outside. That's kind of how I think about it. But again, you can test a value, and that's going to be your graph. 0 didn't work. 0's here. That means it has to shade out. Now you have to write your answer. And your answer, we're going to define this piece and this piece. So this is going to be x is less than or equal to -9/2, or, and you need the word or, x is greater than or equal to 4. That's going to be your answer. Okay. Parabola. Okay, again, another quadratic. So for this one, when we're doing this, I actually kind of keep the inequality here for this, and I just kind of, I want to figure out what the factors are. So when I'm doing this, just get smaller font. When I'm doing this, I'm trying to think of what multiplies to a -15, okay? What multiplies to a -15 and adds to 2. So that's going to be a 5 and a -3. So this is going to be an x plus 5 and an x minus 3. And we want that to be less than or equal to 0. Well, what would make it 0? -5 would make it 0, and 3 would make it 0 because they make these 0. So those are going to be boundary points. I have one at -5, I have one at 3. Again, I need to decide open or closed. So I look here and it's going to be closed because of the equal. So this and this are solutions. And then again, you can test a number. An easy number to test would be 0 because 0 is in between here. So I'm going to put 0 in here. So when I put 0 in here, this is going to be 0. When I put 0 in here, this is going to be 0. So I get a -15 less than or equal to 0. And I want to decide if that's true or false. -15 is smaller than 0, so I am going to shade in between. Now, the way I think about it, instead of testing a value, I know that these two boundary points, if I'm thinking of this almost as an x-axis, this would be an x-intercept, this is an x-intercept. This is a parabola. I know this parabola is an open-up parabola because I can see that it has a positive a. And if I'm thinking about this as on a graph and I want where my graph is below the x-axis, basically, I want it to be less than 0. Here, right here, this is above. This is at the x-axis. This is below, at the x-axis above. So where is it below? From here to here. Okay, so I get the same answer, just another way of thinking about it. Okay, so now for my answer, when it's these in-between ones, you want to start with your smaller. And it's always going to be less thans if I start with my smaller, and they should both point the same direction. Less than or equal to x, less than or equal to 3. If you're giving me these pointing in opposite directions, that's not right. Okay. And the last ones here. This is one that I'm graphing. Okay. I have a parabola and an exponential. So for the parabola, my vertex is going to be -2, 6, -2, 1, 2, 3, 4, 5, 6, kind of off the graph a little bit. And if I wanted to kind of accurately graph this, I look here, and this is an up and down parabola. This is a regular parabola, which means 1 squared and 2 squared and 3 squared. I don't times it by anything because I don't have a stretch. So if I go out 1 squared is 1. I'm going to go down 1 because it's a negative in front. I go out 2 squared is 4. Because of the negative, I'm going to go down 1, 2, 3, 4. 3 squared is 9, 1, 2, 3. So I'm going to go down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to connect. And when I connect, I want to pay attention to open or close. I'm not open or close, sorry, this is a dash or solid, okay? Because there's no equal there, it's going to be dashed. So that means that the values on my parabola are not solutions. It's just going to be kind of a boundary. And then I want to decide if I'm shading above my parabola or below my parabola. So you can test a value, but this is saying I want my y's under my parabola. I want them less than my parabola. So that means I'm going to shade below. So I'm going to get a yellow to shade. So I'm going to shade in yellow just so I can kind of a little thicker. Okay, so this is where I would be shading for this graph. This one here is an exponential. And for this exponential, what I'm going to be doing is I am going to be having an asymptote at -4, y equal -4. Oops, I forgot I changed it to thick. Okay, so I'm going to have y equal -4. That's my asymptote. This +2 means that my graph got shifted to the left 2. So you're kind of thinking of -2, -4 as kind of a locator point. So -2, -4 puts me right here. This is where I'm going to start my graph. This is going to be starting my graph. So this is where I'm going to do 3 to the 0. And then I go over 1, 3 to the first. 1, 2, 3. So 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so forth. Now, when I'm doing this, again, I look here, this is solid. So I'm going to get a solid curve. Okay, and for this one, I want to shade above. It's greater than or equal to, so I need to shade above it. So I'm going to do it in kind of a light blue. And I want to see where both graphs are shaded. Okay, so I'm going to be shading above this. So above this would be like this. And you see here, this is where I have both colors. So this is where my answer is right here. Okay, and I'm going to kind of make it in green because my blue and my yellow are going to make green. We're going to make green. Let me get my green, sorry. So this is going to be where the solution is. Okay, so everything in this section makes nothing true. Everything here in the yellow makes my parabola inequality true. Everything here in blue makes just my exponential true. And here where both colors were, that's my answer. That makes both true. And last one. Okay, this is a square root graph. Again, this is, I mean, not graph, but square root equation. This is, again, review from past chapter. We want to get our square root by itself. Remember, square roots, principal root can always is going to equal a positive. So once I get my answer, I want to make sure that this is a positive. So let me just make this center. So I am going to square both sides. So I'm going to get 8x plus 24 equals x plus 3 squared. And remember, x plus 3 squared is really an x plus 3 times x plus 3. And that, if you're thinking about it as a diamond, would be a 3 and a 3, which multiplies to 9 and adds to 6. So this is not x squared plus 9. This is x squared plus 6x plus 9. Again, it's a perfect square trinomial. So I've also taught you guys that you would square the front, multiply together and double. Okay, so 3x double, 6x square, 9. And again, another quadratic. So I'm going to get everything on this side. So I'm going to have x squared. I'm going to subtract 8x, so negative 2x. And I'm going to minus 24, so I get a negative 15. And again, a quadratic. I'm just going to do a diamond for this. This time I know the top, it has to be a negative 15, and the bottom has to be negative 2. So what multiplies to negative 15 adds to negative 2, a negative 5 and a 3. So I'm going to get x minus 5, x plus 3. And so I get x equal 5 and x equal -3. Now, you want to check to make sure that this is not negative. It can be 0, just cannot be negative. So if I put 5 in here, that is going to make it positive. So that's going to be an answer. If I put -3 in here, it makes it 0, but that's okay. It just can't equal a negative. So you've got 2 answers. Okay. So again, you want to make sure that you understand how to do these problems on this D-Day and the last D-Day for the first half of the information from chapter 7. The next half is going to be law of sines and law of cosines, okay, that you're going to need to make sure you know how to do.